Hello students, welcome. Previously, lesson 4, form 3 topic 4, we were dealing with compounds of nitrogen where we have started with oxides of nitrogen, and specifically we were dealing with nitrogen 1 oxide, which we have said it's also known as dinitrogen oxide. So today, lesson 5, so we are going to go to the second oxide of nitrogen, which is nitrogen 2 oxide gas, which we have said is also known as nitrogen monoxide, and this chemical formula is NO. Let's start with first of all laboratory preparation of nitrogen 2 oxide gas, and we are going to have two reagents. One of them is copper tannings, and the other one will be dilute nitric 5 acid. And nitrogen 2 oxide gas will be collected over water method. This is nitrogen 2 oxide gas will be collected over water method. So we're saying nitrogen 2 oxide is produced when copper is reacted with dilute nitric 5 acid. So the reaction for the formation of nitrogen 2 oxide will be copper tanning, which are solid, will be reacting with 8 moles of nitric 5 acid solution. What we are going to get is copper 2 nitrate solution. We are going to get 4 moles of water, which is liquid, and we are going to get 2 moles of nitrogen 2 oxide gas. So here we can see some observations. The observations that we are going to have in this conical flask will be the red brown solid dissolves in the acid. Which acid? That nitric 5 acid. Then the other observation that we are going to see will be a blue solution is formed. That blue solution is due to the formation of the copper 2 nitrate solutions, which are blue in color. So next again we're seeing the nitrogen 2 oxide is oxidized by oxygen in the flask to form red-brown fumes of nitrogen peroxide. The reaction will be 2 moles of nitrogen 2 oxide gas will be reacting with 1 mole of oxygen gas, giving us 2 moles of nitrogen peroxide gas, which are the red-brown fumes. Next, we are saying the fumes gradually disappears as the air in the conical flask is exhausted. And we are saying nitrogen peroxide formed dissolves in the water in the trough. Remember, here we are having trough. That means the nitrogen peroxide formed will be just dissolving in the water. So we're saying next, nitrogen 2 oxide is collected over water method as it is slightly soluble in water. So that means the gas that we are going to collect in that gas jar will be nitrogen 2 oxide gas. Next, let's go to the physical properties of nitrogen 2 oxide gas. Number 1, we are saying it's a colorless gas. Number 2, we are saying it's slightly soluble in water. That's why we are collecting by over water method. And number 3, we are saying it has no effect on litmus paper, hence it is a neutral gas. So remember, the other example of a neutral gas that we had was nitrogen 1 oxide gas. Next, let's go to chemical properties of nitrogen 2 oxide gas, and we are going to start number 1, that's reaction of nitrogen 2 oxide with heated metals. And we are saying when nitrogen 2 oxide is passed over heated metals, metal oxide and nitrogen gas are formed. Example, when nitrogen 2 oxide is passed over heated magnesium, magnesium oxide and nitrogen gas are formed. And the equation for that reaction will be 2 moles of magnesium solid will be reacting with 2 moles of nitrogen 2 oxide gas, giving us 2 moles of magnesium oxide solid and also 1 mole of nitrogen gas. Next, let's see observations made. We're having magnesium metal continues to burn in nitrogen 2 oxide. A white solid is formed. Then number 3, even a colorless gas, which is nitrogen gas, is formed. The result for those observations are we're seeing the heat from burning magnesium decomposes nitrogen 2 oxide into nitrogen and oxygen. Therefore, the oxygen produced is the one supporting the burning of magnesium and reacts with it to form a white solid, which is magnesium oxide, and nitrogen gas, which is the colorless gas. Example number 2, we are saying when nitrogen 2 oxide is passed over heated copper, copper 2 oxide and nitrogen gas are formed. The equation for this reaction will be copper solid reacting with 2 moles of nitrogen 2 oxide gas. We are going to get 2 moles of copper 2 oxide solid and also 1 mole of nitrogen gas. Let's see the observations made. The first observation that we have is red brown solid changes to black. Then the second observation will be a colorless gas is formed or is produced. So the reason will be we are going to say copper reacts with the nitrogen 2 oxide to form black copper 2 oxide and nitrogen gas, which is the colorless gas. The second chemical properties of nitrogen 2 oxide is reaction of nitrogen 2 oxide with nonmetals. And we are saying phosphorus burns in nitrogen 2 oxide to form phosphorus 5 oxide and nitrogen gas. The equation for that reaction will be phosphorus reacting with the 10 moles of nitrogen 2 oxide gas, giving us phosphorus 5 oxide and also 5 moles of nitrogen gas. Next, we are going to go to test for nitrogen 2 oxide, or we can just even continue with the chemical properties of nitrogen 2 oxide, and we can put this one number 3. We are going to say reaction of nitrogen 2 oxide with air, and we're talking about oxygen. So we're saying when nitrogen 2 oxide gas is exposed to air, it is readily oxidized by oxygen in the air to form red-brown fumes of nitrogen 4 oxide gas. So for the equation for the reaction will be 2 moles of nitrogen 2 oxide gas reacting with 1 mole of oxygen gas, giving us 2 moles of nitrogen 4 oxide gas. So this is a test of nitrogen 2 oxide gas. Number 4 as the chemical properties of nitrogen 2 oxide gas, or number 2 as the test of nitrogen 2 oxide, we're seeing reaction of nitrogen 2 oxide with iron 2 sulfate solution. We're saying when nitrogen 2 oxide is bubbled through iron 2 sulfate solution, the solution turns dark brown. Initially it was pale green, it will turn dark brown. What is the reason? And we are saying this is due to the formation of iron 2 sulfate nitrogen 2 oxide complex, and that's how it's written in the formula. It will be iron 2 sulfate dot NO, that's nitrogen 2 oxide. So the reaction will be iron 2 sulfate solution, which were pale green in color, will be reacting with nitrogen 2 oxide gas, which are colorless gas. What we are going to get will be dark brown solution, and that dark brown solution will be iron 2 sulfate nitrogen 2 oxide complex. Lastly, learners, let's go to the uses of nitrogen 2 oxide. We have only one use, and we're saying it's used as an intermediate product in the large-scale manufacture of nitric 5 acid in the Stuart process. Learners, that's the end of our class today. Thank you for watching.